Push that rock here with Simpson math. Let's talk variables. We're going to study variables in this course, and we're going to divide them up into two types, quantitative and qualitative. So quantitative has the word quantity in it. That's exactly what those types of variables are, ones with quantities, whereas qualitative has quality in it, and those variables are variables that have qualities or categories. Okay, so an example of a qualitative variable is maybe the color of somebody's eyes. They're either blue or hazel or brown, whereas quantity might be something like the radius. Do eyes have radii? I don't think so. But anyway, something like length or baby weights or something, the number of eyes a person has. You say, well, everybody has two. No, my wife works at a place where lots of people do not have two eyes. Okay, so these quantitative variables divide up into discrete and continuous, and that's where the complication becomes. So continuous variables are ones where there are no impossible values existing within an interval of possible values. Now, sometimes we round off, or our method of measurement limits us to certain possible values. We're discounting. If your method of measurement is what's limiting you, don't worry about that. Or if you're rounding off, don't worry about that. But if it's possible to have any value within a range of values, then you're continuous. And examples are volume, like volume of gas, length, like the length of a fish, weight of a baby, force applied to something, area you have to paint, or even prices on a continuous quantity. So like when you go buy gas at the gas station, you notice that the price isn't limited to just $9.99. It's got that extra, or I guess that would be a little high for gas, but $1.99, then it has another 99 after that. That's because you can actually, you're tying the price to a volume, and therefore the price can be as fine as you like it to be, really. Of course, they automatically round off to the nearest penny, in America anyway, where that's our smallest denomination of our legal tender. So, but rounding, remember, you discount rounding. Okay, so if we may round off to the nearest penny, but if it's a price of a continuous quantity, it's actually a continuous variable. Now, discrete variables are when you have impossible values exist within an interval of possible values. And the most common example is a count. If I'm counting how many chickens are in the chicken coop, I can count 1, 2, 3. I can't have 2.5 chickens. That would be a dead chicken. Or it might be, you might say, well, what about a chicken that's lost a leg and a wing from a fight with a fox? Well, it's still a whole chicken. It's just been damaged. You don't start counting. It's still a creature, and you count it as a whole creature. So now, prices on discrete items like eggs, okay? If I'm going to price maybe a dozen eggs, I can have 2 dozen, I can have 3 dozen, I can have 4 dozen. Okay, you say, well, what if one egg's broken in there? Well, you're either going to pay for that whole dozen, or you're going to give it back to them, and they're going to go, oh, and replace that broken egg. So you're only buying a dozen, 1 dozen at a time. So that's either 1, 2, 3. So that's discrete. So the price on those eggs will be discrete. I mean, you might pay $1.99, but you can't pay $1.99.5. And it's not rounding that's causing that. I mean, it's just the fact that there's going to be a price, and it has to be limited to a penny, to the fact that you're only buying so many of these eggs. It's not a continuous volume like gas, where you could pump out 12 gallons or pump out 12.01 gallons or pump out 12.00001 gallons, and they have to keep refining the price based on how much gas you're pumping. Here, they don't have to keep refining the price based on the number of the dozens of eggs you're buying. I hope that makes sense. Math made simple and sometimes confusing as Simpson math.